Properties of Fourier transform. Linearity property. If x of t Fourier transform to x of omega and y of t Fourier transform to y of omega, the linearity property says that a of x of t plus b of y of t, the Fourier transform for the signal is a x of omega plus b y of omega. Next is time shifting property. If the signal x of t is Fourier transform to x of omega, the time shifting property states that x of t minus t naught Fourier transform of x of t minus t naught is nothing but e power minus j omega t naught into x of omega. The frequency shifting property states that e to the power j omega naught t of the original signal x of t can be Fourier transformed to x of omega minus omega naught, which is the change in the frequency. The time reversal property for the signal x of t Fourier transform to x of omega says that the Fourier transform for the inverse of x of minus t is same as that of the Fourier transform of x of minus omega. Similarly, the scaling property states that x of a of t is equal to 1 by determinant of a into x of omega divided by a. Next is differentiation and integration property. Differentiation property states that the differentiation of d of x of t dt, the Fourier transform will be j omega into x of omega. Similarly, for n times it will be j omega to the power n into the Fourier transform x of omega. Likewise, the integration property states that the integral of x of t dt can be Fourier transformed to 1 by j omega into x of omega. For multi-integral, the equation for x of t dt is 1 by j omega to the power n into x of omega. Next is multiplication property. The multiplication of two signals x of t dot y of t can be Fourier transformed as x of omega into convolution y of omega. That is, the multiplication of two signals can be represented as a convolution of Fourier transform of the two signals. Similarly, the convolution of two signal is equal to the product of 1 by 2 pi into the Fourier transform of the two signals. Now let us see a small example problem for Fourier transform. So the question is, find the Fourier transform of the signal x of t, where x of t is given as x of t equal to e to the power of minus a determinant t such that a is greater than 0. So solution, the signal can be rewritten as x of t equal to e to the power minus a determinant t is equal to e to the power minus at when t greater than 0 and e to the power at when t less than 0. So the Fourier transform x omega of t is equal to integration minus infinity to 0 e to the power at into e to the power j omega t dt plus integration 0 to infinity e to the power minus of at into e to the power minus of j omega t dt. Here the common terms are taken out, and now you are substituting the integration condition so that we get 1 by a minus j omega plus 1 by a plus j omega. On simplification, we get qa equal to a square plus omega square. So the Fourier transform of the given signal is nothing but 2a by a square plus omega square.